we will take the nitrogen compounds. Under this, all the compounds containing NH2 are the derivatives of the ammonia. They are called amines. First, the RCN and RNC. These two compounds are called alkyl cyanides. Alkyl cyanides and alkyl isocyanides. Cyanides means CN, cyanide. Reverse is called, that is the isocyanide, alkyl isocyanides. Alkyl cyanides are called actually the RC triple bond N. Okay, these are all called and the cyanoalkanes. Cyanoalkanes are up to this the carbon alk. This is a systematic nomenclature. Alk N-nitrile. N-nitrile. Whereas the alkyl isocyanide will have a triple bond C. N will have a plus and minus. Now the alk stands only up to this carbon only. Alk. This is called alkyl. The carbon is said as a carbyl. This is called as amine. This is the general IUPAC nomenclature. For example, if CH3, C and triple bond N is there, now it's a specific example called including the carbon. So therefore, it is called as ethyl ethane nitrile. Ethane nitrile, commonly known as methyl radical and function. It is also known as commonly methyl cyanide. Methyl cyanide is the common name. Ethane nitrile is the IUPAC name. Now here similarly an example for this class CH3 N with the triple bond C with plus and minus. Now the root word is only one carbon, that is meth. Therefore, methyl carbyl amine. This is IUPAC name. The radico-functional name is methyl isocyanide. May also be called as methyl isocyanide. Right? Okay. So methyl cyanide and methyl isocyanide are the common names systematically according to the IUPAC nomenclature. Even this carbon comes into the main chain. So therefore, two carbons, so ethane nitrile. Whereas here the longest chain here is only one carbon, because this is a discontinuity of the nitrogen is there. Therefore, that is separate, this is separate. So methyl carbyl amine, that is the IUPAC nomenclature. Now let us see how these compounds are prepared. Preparation methods. Let us take commonly, one side we will take the cyanides preparation, the other side isocyanide preparation. There two methods are in practice. One is from alkyl halides. From RX, alkyl halide means a halogen containing compound you take and then treat it. An example, if a alkyl chloride you take. Alkyl chloride, treat it with the either with the sodium cyanide or with the potassium cyanide. In both the cases, Na will be the plus, the carbon will have a minus charge, the triple bond will be there. The minus as such will have a nucleophilic substitution and substitute the Cl and you will get the R with the cyanide. Na and Cl will go out as a NaCl as a byproduct. Okay. So cyanides can be prepared by this way. Similarly, here also from the alkyl halides. Alkyl halides can be used and prepare the isocyanates also, but what you are taking is, you take alkyl chloride, treat it with the silver salt of the cyanide, not the potassium or sodium. In this case what happens, and the silver and the carbon happens to be the difference in the electronegativity is not like this, but here less, therefore the bond between the silver and the carbon is slightly less polar, so it has got some the covalent character, and here the a lone pair on the nitrogen will take this advantage of the attacking as a nucleophile. Here the bond is open and there is a minus charge clearly on the carbon. So, the carbon attacks, so the attachment is through the carbon. Now, here the bond between silver and the carbon is not that much polarized. So, a lone pair on the nitrogen will be attacking. Now, the compound formed is alkyl NC. So, the valency of the nitrogen is 4, therefore plus, and the minus will be there on the carbon. So, the methyl isocyanate, alkyl isocyanate type of the compound is formed. Now, we have one comparison, both starting materials are alkyl halides. You can take chloride, bromide, iodide. Iodide, if you take, the reaction is very fast, but the cost wise, if you take, the preferable is chloride. So, both potassium and sodium salts are giving the cyanide, whereas if you take silver, the cyanide, NC is the product. Cyanides can be prepared by removal of water. Removal of water methods are called dehydration methods. Dehydration methods. These dehydration methods, there are two methods are there. One is the dehydrating the cyanides RCONH2. They are called acid amides. These acid amides, when you use P2O5, P2O5 is the anhydride of the phosphoric acid, will take away the H2O, the hydrogen and the oxygen is removed, and you will get the cyanide. Plus this water goes with the P2O5, that converts into this corresponding phosphorus acids. Similarly, you can also take an aldehyde derived compound, this is known as aldoxime. Aldoximes undergo dehydration with the agents like you can take P2O5 or acetic anhydride also you can take. AC stands for the CH3CO, taken twice O stands for the acetic anhydride. When acetic anhydride is added and heated, this water HOH will go out and join with acetic anhydride, that becomes into acetic acid. 2 moles of acetic acid is formed. This will become into cyanide or with the cyanide. The ACO plus water will become 2 moles of ACOH. Acetic acids are formed. So, in both the cases it is a dehydrated. First one is a amide, acid amide. Acid amides undergo dehydration with phosphorus pentoxide. Aldoximes undergo dehydration either with P2O5 or with acetic anhydride, you will get the cyanides. This is the second method. The method is based on the removal of water, that is known as dehydration. From the molecule H2O is detached, so therefore corresponding cyanides are formed. In the other case, you have here also isocyanates also can be prepared by using one name reaction called carbyl amine reaction. Carbyl amine reaction. This is popularly also known as CAR, carbyl amine reaction. Aliphatic or aromatic compounds when treated with the chloroform and KOH. Chloroform and potassium hydroxide heated. 3 moles of KOH is used, 3 OHs and 3 Cls forms 3 KCl. 3 OH, 3 Cl, 3 K and 3 Cl forms into the 3 KCl. 3 OHs and 2 hydrogens here, 1 hydrogen here forms 3 H2O molecules also. Then what is left over? R with N here, carbon here, these two will join, you will get the RNC. This is a reverse type of the compound, not CN, but it is a NC. Such a type of compound is called isocyanate. Isocyanate is commonly also known as carbyl amines. Therefore, the carbyl amine is formed. So, the reaction is known as carbyl amine reaction. As we see, these carbyl amines will have a very bad smell, that is foul smell is there. Foul smell will be there. So, the smell is very unique here. So, due to this smell, we can differentiate the 1 degree amines, and 2 degree amine, 3 degree amines will not give this reaction. That is why in the amines chapter we have noticed, if a one is a 1 degree, the other one is a 2 degree, you can use this test, only primary amines will give this test. Even chloroform and CCl4 also can be differentiated using this smell. The smell is formed only in the case of 1 degree amine with KOH will give this reaction. Isocyanates are formed. So this is the another method for the preparation of the isocyanate. So there are two methods for the cyanides preparation and two methods for the isocyanide. One method is common to both. Alkyl halides we have taken. Used sodium or potassium will give cyanide. Silver cyanide will give the isocyanide. Similar the way we can take the one or two properties of the cyanides and the isocyanides. It's a very small topic where containing two preparations and two properties are over enough. Properties. In this properties, first property, take it as a hydrolysis. Hydrolysis of the cyanide, hydrolysis of the isocyanide. Cyanides will have a triple bond attached between the carbon and the nitrogen. When you hydrolyze, you take the sodium hydroxide and mix some water. This is called what? Alkaline hydrolysis. The bond opens into thrice. 3 HOHs are added. H is added to the more electronegative element, OH is added to the less electronegative element. Like that, 3 times these bonds open up into HOH joining. So 3 hydrogens with nitrogen, ammonia will be liberated. The medium is also base, so the base liberated will have a repulsion. Immediately the ammonia gas will come. However, from this side you will get a molecule like this, a carbon with 3 OHs. 3 OHs is unstable. So what happens is the water is detached and the compound will become into a RCOOH. But however, even this will not be the final compound. This becomes into the tri-OH, 3-hydroxy compound. The trihydroxy eliminates water, you will get acid. Because the medium is basic, you always the compound will be in the form of the salt of that acid. Sodium salt of the carboxylic acid plus ammonia gas. That is the reaction when cyanides are hydrolyzed. Similar the case, let us take isocyanide. When isocyanides are taken, NC compounds are hydrolyzed with the sodium hydroxide and the water, that is alkaline hydrolysis if you do it. Even CN bond undergoes a breakage, but this side you will get RNH2. The other side you will get a carbon is oxidized to carbon dioxide and liberated. So isocyanides will be liberating the carbon dioxide and the cyanides will getting the amines. Even before the getting this one, you may find a carboxylic acid, that is the formic acid may be obtained, HCOOH. This undergoes further hydrolysis to liberate the carbon dioxide. So you will get a 1 degree amine, not the ammonia gas. Ammonia is attached to the R, therefore ammonia is not released. Here the nitrogen is attached to, isn't it? Nitrogen is separately attached, therefore this will become detached. That is separated by triple bonds, therefore on hydrolysis N is detached. So here N is attached to the alkyl group, so therefore RNH2, that is 1 degree amine is coming, 1 degree amine. Primary amines will be the major products. Similar the case, you can also notice another property called a reduction property. Even this reaction will be taken as a differentiation also. How do you differentiate the cyanides and isocyanides? Cyanides, when you hydrolyze, ammonia gas will come. Ammonia can be tested with a litmus paper, wet with a red litmus paper, wet with water and exposed to the gas which is liberated, it becomes into blue, that is the test. Or the liberated ammonia pass into the Nessler's reagent, which becomes a red coloration. So ammonia will have a pungent smell, the smell also one of the criteria. So somehow the cyanides liberate the ammonia. How do you test the ammonia is a different issue, but this liberating the ammonia is for the cyanides, whereas isocyanides will liberate the 1 degree amines that will not be given out of the flask, the test tube, so therefore you don't find ammonia liberation there. Now reduction may not be the differentiating test, but reduction also will give a different answer. Cyanides with hydrogen and nickel. So the hydrogen is added twice, 2 moles will be added. You can't cut the total molecule, but 2 pi bonds are there, twice you can add hydrogen. So C will become CH2, N will become NH2. So 1 degree amines are formed. Whereas isocyanates, when you reduce with the same reagent, isocyanates will have a N with triple bond C. When you add hydrogen, here also 2 sets of hydrogen is consumed in presence of a nickel or palladium platinum catalyst, but the hydrogen, the N will get a positive charge, one hydrogen is exchanged, and what happens is RNHCH3 is formed. This is a 2 degree amine, that too specifically N-methyl containing 2 degree amines are formed. So here 1 degree aliphatic amines, if you take aromatic, attach it to CH2 and H2, again aliphatic amine will be produced. So okay, 1 carbon extra when compared with the number of carbons in the alkyl will be same, plus this carbon also becomes CH2. So 1 degree amines will be formed in the cyanides reduction. 2 degree, that too specifically N-methyl 2 degree amines are formed in the reduction of the isocyanates. So this is all about the cyanides and the isocyanates. The next topic will be the diazonium salts. That is also a small unit, comes under the same topic called nitrogen compounds. Next topic is diazonium salts. Diazonium salts. They may be represented like RN2Cl, or maybe an aromatic ARN2Cl. In the case of aromatic, they have a really wonderful applications. So let us say symbol with AR, simplified example will be the benzene with N2Cl. This is called what? Benzene diazonium chloride. Benzene diazonium chloride. In the aliphatic case, diazonium salts are unstable, they decompose and give the alcohols. Therefore, benzene diazonium chloride is a suitable example to discuss the different applications. Now, how this the benzene diazonium chloride is prepared? The salt, therefore, ending with diazonium chloride, just like sodium chloride. Its nomenclature itself, benzene diazonium chloride. You too can say phenyl diazonium chloride. How we prepare means take a corresponding aromatic amine RNH2, treat it with a mixture of NaNO2 and HCl. This NaNO2 and HCl react and generates a unstable acid called nitrous acid. Nitrous acid will have a double bond O and a single bond OH. You can also represent this as a HNO2. This reacts with this. A lone pair of this amine will attack on the N of the nitrous acid. So there is a N bond is formed. Later one water molecule will be dropped. Finally, the compound undergoes a small rearrangement and gives the what? N triple double bond NCl. This is called what? Benzene diazonium chloride, which has another resonance structure also. A lone pair and the nitrogen can be given like this, and the Cl will go out, then it will become a polarized structure. There is an equilibrium between the two structures of diazonium chloride. So N will have now a triple bond. N will have a plus outside Cl. This is the polarized structure of the diazonium compound. This is the molecular form. This is the ionic form, or ionized into N plus and Cl. Both are called phenyl or benzene diazonium chloride. The reaction temperature should be between 0 to 5 degrees centigrade, for which generally the salt and water mixture, that is salt mixture, ice mixture is taken, and aniline is freezed, and a aqueous solution of sodium nitrate and HCl is added. Then you will get this reaction called what? The reaction is also known as diazotization. One nitrogen compound become into a compound containing 2 nitrogen. So the process is called what? Diazo, means 2 nitrogens getting diazotization. diazotization. The reaction is called diazotization, just like ester formation is called esterification. So, this is 2 nitrogen getting into the molecule, 1 nitrogen compound becoming into 2 nitrogen, therefore, this is called diazotization. So, diazotization of the aniline or 1 degree aromatic amine gives the color. If there is a methyl group, okay, so that methyl will be there, that is intact, but primarily the NH2 of aromatic becomes into diazone. If aliphatic amine is taken, you will get aliphatic diazonium salt, but they are very unstable. If there is any water that decomposes into the aliphatic, that is alcohol. So, therefore, in the case of aromatic only they are very important. How you prepare means by aniline diazotization reaction, benzene diazonium chloride is prepared. Now, the properties of these diazonium salts. All these properties may also be listed as the synthetic application. They are all synthetic applications. Synthetic applications of diazonium salts is nothing but the properties of diazonium, because every reaction happens to be useful reaction in the synthesis of the different organic compounds. Okay. Now, the reactions can be broadly classified into the 2 types. One is, first type is the group will be replaced and a new group will come into the compound. Which group? The NNCl will go out and a new group come. This is by, so the first type reactions are by substituting N2Cl group. The group is removed and in that place a new group comes. So, this is first type of the reaction. Another second type of reaction, the nitrogens are not going out of the compound, it will be there in the compound and some useful products are formed. In this, let us list out the now 1, 2, 3. The first one is substitution by chlorine, bromine and cyanide. All these groups can replace this N2Cl, and it is a known reaction called Sandmeyer reaction. Sandmeyer reaction, known reaction. It's a name reaction called Sandmeyer reaction. What is this reaction? You take benzene diazonium chloride, right, N2Cl, add the HX in presence of CuX, where X can be a Cl minus or Br minus or cyanide minus. That means you can take HCl and CuCl, HBr and Cu. So, X will be replacing this one. So, you will get a X containing benzene. So, for the preparation of the chlorobenzene, bromobenzene as well as cyanide containing benzenes can be prepared from this N2Cl. Okay. Now, this reaction has some synthetic applications. You see how the reaction has an application. One of the application is, how do you convert NH2 into CH2N2. This is called aniline. This is called a benzyl amine. So, this is a beautiful conversion. How do you convert aniline into benzyl amine? Okay. This reaction, how you prepared this compound from aniline only. So, therefore, first step is you convert aniline into first diazonium salt by adding the HNO2. That is, by taking sodium nitrate and HCl, you will get HNO2. In presence of HCl, let us say 0 degree centigrade, you will get the diazonium salt N2Cl. Then you add the HCN in presence of CuCN. So, what you will get? You will get the cyanide containing benzene, benzonitrile or cyanobenzene. This cyanobenzene, you add hydrogen nickel, reduction of this, you will get the carbon is just now we have seen cyanides will give the CH2, N will become NH2. This is your target. So, from aminobenzene to the that is phenylamine, how do you prepare? First step is first convert aniline into diazonium chloride. Diazonium chloride to this is X preparation. X wherein cyanide. Cyanide, if you want, you take HCN. CuCN is a catalyst. In presence of the copper cyanide, the reagent is HCN. That cyanide minus will replace the whole group and you will get cyanide. That cyanobenzene and reduction you are getting. So the net reaction, just it looks like that. How do you get that CH2 unit? The NH2 is already there in the compound. That CH2 how to get? It's a wonderful synthetic application of this particular reaction. You can, how do you convert aniline into benzoic acid? This is also a good question. Aniline into benzoic acid. How do you get this benzoic acid? Means cyanides and hydrolysis will give the COOH. So first convert into diazonium salt. That NH2 is converted to N2Cl. The N2Cl then convert into the CN. Okay, CN hydrolysis, you will get this group. So first you will get a diazonium chloride to Sandmeyer reaction, cyanide to the COOH. Directly COOH introduction into the benzene ring is not possible. So therefore go to for the nitration, diazotization and reduction, aniline to this one. So the amino group also directly you cannot. You can go for the benzene, nitration reduction with tin HCl. You will get this aniline to the corresponding benzene, that is diazonium chloride, then cyanide, and then the hydrolysis will give the cyanides, hydrolysis will give the carboxylic acid, cyanides and reduction will give the 1 degree CH2 NH2. So this is the number one reaction, Sandmeyer reaction. So N2Cl when treated with HX and CuX, X containing compounds can be prepared. Okay, then let us go for the some other applications, that is properties of the compound. One is substitution by this one. Second one is there is another reaction just like Sandmeyer reaction. There is another reaction called Gattermann reaction. In this reaction also we are able to convert diazonium chloride into the X. But here X containing diazonium chloride you take, heat it with the copper powder. Just heat. What is the advantage of this reaction over the name reaction called Sandmeyer means? In this Sandmeyer, CuX is the catalyst we are using, which is Cu is a +1. The oxidation state of this copper salt is +1, which is slightly less stable. Therefore, the much of the time goes for the preparation of catalyst itself. Here, that catalyst is not necessary. You just take direct copper powder. But what type of X should be there here? The desired X containing. That means if I want bromine, you take a diazonium bromide. If you want cyanide, diazonium cyanide. How do you get diazonium cyanide? While in the preparation itself, you add sodium nitrate and instead of HCl, you take H cyanide. That is hydrogen cyanide. You will get cyanide. This compound will give the X will come into the compound. X containing compound will come. Again X can be here, again X can be chloride, can be bromide, all or cyanide. Cyanide minus is following the halides properties here. So therefore it is called pseudo halogen. It is following the, it is not a halogen family but still following the halogen property, therefore it is called pseudo halogen. So in the Gattermann reaction, the reaction is made easy, simple. That is one of the application of this one is here. So just like Sandmeyer reaction, only thing is we are not using the unstable copper salt here. Copper powder you are using, but the halogen which you want should be there in the diazonium chloride already. Heat it with the copper powder, you will get the X containing benzene. And the third application is introduction of the fluorine. How to get a fluorine into the benzene? Benzene taking a fluorine and the ferric brom fluoride, you won't get this reaction. Instead, you take the diazonium salt, N2Cl, treat it with the mixture of HF plus BF3, boron trifluoride. These two initially forms a mixture called H plus and the BF4 minus. A salt is formed. This salt will react this one and then gives a unstable salt like N2 plus and BF4 minus. This salt is formed. This is called benzene diazonium fluoroborate or fluoroborate. This salt on slow heating heat it slowly, the BF3 will go, N2 will go, F will come into the compound. So finally what you will get is a fluorine containing fluorobenzene comes, okay, fluorobenzene preparation will become easy. Direct fluorination of the benzene is a very highly violent reaction. You cannot control the reaction. Fluorination is a very fast reaction, therefore that is not the direct method. Instead, go for the diazonium chloride. Its salt is prepared with using this one, and then the salt is slowly heated as per the demand. That is, if the reaction becomes violent, slowly heat it very slowly, otherwise slowly heat it, you will get this fluorobenzene. Introduction of the iodine. How to get iodine? Iodination is a very slow reaction. Even after the several hours, you will get a very small quantity, and the byproduct happens to be Hi. It is a reducing reagent, therefore reaction goes back. But on the diazonium chloride, it is very easy. Take the diazonium chloride, heat it with the potassium iodide aqueous solution. Just dissolve the potassium iodide in the water, then add it to this one. It has so happened H minus is a very stronger nucleophile, replaces the whole N2Cl, and you will get iodo-benzene. So the iodo-benzene preparation has become very easy through this N2Cl. What is the credential or the credit? The plus point of this the N2Cl means N2Cl is the best outgoing group, taking the 2 electrons. On the benzene, you will get a benzene phenyl carbocation, which is highly unstable. So immediately the I minus will attack and then do this work. So similarly the OH, a OH minus, all these are all minus groups in fact. OH minus directly on the benzene you cannot introduce. Benzene undergoes electrophilic substitution as a characteristic, but not the nucleophile. But this diazonium chloride, just add some water and boil it. Boiling with the water, you will get this N2Cl will go and OH will come. This is also a wonderful application. Getting the phenol commercially, it is possible. Preparation of phenol from the benzene, benzene for nitrate it, then reduced to aniline, aniline diazotized and boil with water, you will get the phenol, which is a commercially befitting type of the reaction. Phenol is prepared, that is whole N2Cl is replaced by the OH group. NO2 group also can be introduced. Benzene diazonium chloride, sodium nitrate, copper in presence of copper salts, HNO2. Nitrous acid, anyhow in the diazotization itself we used nitrous acid. That nitrous acid with the sodium salts in presence of the copper salts, copper plus 1 salts if it is there, this will catalyze the reaction to get the nitrobenzene. In fact, everybody prepares nitrobenzene to aniline, but if somebody asks an aniline to nitrobenzene, you can oxidize. However, this is the best method. The aniline diazotize it, then add nitrous acid, and then in presence of the copper salts, it will NO2 will replace this reaction. The fluorination is also a name reaction called Schiemann reaction. SCHIEMANN, Schiemann reaction. Schiemann-Bald reaction or Schiemann reaction. It is a fluorination reaction, is specifically there is a name. Introduction of a phenyl group. Diazonium chloride undergoes a replacement of this whole N2Cl with the phenyl. Take benzene in presence of sodium hydroxide. The benzene will replace this N2Cl and you will get another phenyl. So biphenyl compounds are formed. Biphenyl compounds are formed. This is called Gomberg reaction. Gomberg, not much noticed, but it is the name reaction. Gomberg reaction. In this phenyl group entering into the compound. Lastly, finally, but the group entering group is hydrogen, but still we have this wonderful synthetic applications. See how it is. You take diazonium chloride, heat it with the H3PO2. H3PO2. Now tell me, what is the oxidation state of P in this molecule? This is -4, this is +3. So this contains +1. Lower oxidation states for the elements will help for the reduction. So, in presence of water, this hypophosphorus acid. In presence of water, this H3PO2 is known as hypophosphorus acid. In presence of water, it is used as a reducing agent. This converts into finally H3PO3. So, the hydrogens liberated in this reduction from the water, this water acting as a reducing agent, and this benzene will take one hydrogen, becomes into hydrogen containing benzene, is nothing but the benzene, and this N2 is liberated and one HCl is formed. This is the another byproduct. Hypophosphorus acid will become into the phosphoric acid. Okay, this is the reduction reaction. Reduction of diazonium chloride, total reduction of the diazonium chloride, that is N2Cl will go, H is coming. So, we have some beautiful synthetic applications here. One of the application for this reaction is, how do you convert a benzene into tribromobenzene? Tribromo, where are the three bromines? One on the top, one on the third, and 5. So, you call this compound as a 1,3,5 tribromobenzene, 1,3,5 tribromo, or meta dibromo containing bromobenzene, 1,3,5, or symmetric tribromobenzene, because all the three groups are three side, therefore it is also called symmetric tribromobenzene. How do you prepare symmetric tribromobenzene? The answer is here. The problem is here. What is the actual problem here means bromination is not a problem, and benzene, bromine, ferric bromide, heat it, you will get bromobenzene. But the bromine is a orthopara directing. So, next coming bromines goes to the orthopara but not to the meta. So, how to resolve or how to get this type of the achievement means first benzene you convert into the nitrobenzene. What is the reagent used for the nitration? Concentrated nitric acid, concentrated sulfuric acid, 1:1 ratio, mix it and heat it between the 50 to 60, you can prepare. Use tin and HCl, you will get the aniline. Aniline is diazotized. More steps are there definitely. Diazotization is HNO2, that is NaNO2, HCl at 0 degree centigrade, diazonium chloride, right? Before getting the diazonium chloride, now aniline undergoes bromination. Aniline undergoes bromination because our aim is to prepare tribromo. So, here you brominate it, bromine in presence of acetic acid, ACOH. Now, amino group is a very strong orthopara directing. So, therefore, you will get the three bromines, one at ortho, one at para. Tribromo aniline comes. Now, afterwards, this N2Cl somehow you remove it. How to remove? NH2 as such, it is not outgoing group. Amino group is a very strong nucleophile. Incoming is easy, but outgoing is difficult. So, therefore, you diazotize this NH2 by adding the NaNO2 and HCl. So, what you will get is at 0 degree centigrade, this NH2 will become into diazonium salt, N2 plus Cl minus. All these three bromines are there at ortho and para to this diazonium salt. This is what the compound. Now, this N2Cl you are get rid. Remove this N2Cl by using this the reduction method. That is, hydrogen minus is coming in this place by the reduction, the last 8th method. The reduction of this N2Cl will lead to give the hydrogen coming. This is what your target molecule, that is 3 bromines, 3 sides. They are nothing but the tribromo, that is 1,3,5 tribromobenzene. Here hydrogen is there, whether you write it or not, it is not a matter. So, tribromobenzene. So, the method that is asked is also tribromobenzene. The problem is here, first bromination is not a problem, but after first bromine coming, second and third bromine goes to the orthopara. To get the meta orientation, this is the method of solving. Through the diazonium salt, we are able to. That is, after preparing the aniline, brominate it. Aniline is a strong activating. The bromination is very easy. Takes place at ortho, para, ortho according to the NH2, the activation and the directing property. So, therefore, after that the amino group is unwanted now. that is diazotized and removed so that this type of the target molecule is achieved. Like this, we have a wonderful application for this, the 8th, that is a reduction type of the compound. Similarly, the preparation of from benzene to the this type of triiodo compounds, that is you aniline, okay, aniline is the iodized, you will get a nitro compound, aniline, that is amino group iodized, and here also if one more iodine also, 4 iodines or only 3 iodines, all these compounds by just small changes applications you will get this type of the synthetic applications. We have one more here, the reduction. Nitro compound, this is a unique property of this nitro compound. When 2 nitro groups are there, when you use the tin and HCl, usual reduction will give the 2 amino groups, right? Amino and amino. Instead, we have some reducing agents so that only 1 nitro is reduced. Like for example, using the polysulfide, sodium polysulfide, Na2S in n number, huge number of sulfur, sodium, sulfur, 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 sodium, that is called polysulfide, or ammonium polysulfide, NH4 plus taken twice, that means sulfur and sulfur and sulfur and sulfur, at the end and again another NH4 plus will be there. This type of compounds may be represented as ammonia, okay, NH4 taken twice, SX or SN. Ammonium polysulfide or sodium polysulfide in presence of water, aqueous solutions must be taken, otherwise they are not reduced. The aqueous solutions, they reduce one of the amino group, nitro, into the amino. The other will be protected, In such cases, what you can do is, for example, if somebody wants this compound into, one should be bromo, one should be iodo, chloro. How do you convert this into this? Now, if both are bromines, you can diazotize and apply the Sandmeyer reaction, get the bromines. But 1 into bromine, 1 into chlorine, how means, unless you know this specific step, what is that? This is called partial reduction. 2 nitro groups whenever it is there, if you use partial reduction, one can be amino reduced, one is protected. Now, you convert this into the bromine by applying diazonium salt and then Sandmeyer reaction. Then the reduce the second nitro and go for the chlorination through the Sandmeyer or Gattermann. So, one after the one, if you convert both at a time, if you convert, both will become bromo or both will become chloro. But one bromo, one chloro or one hydroxy, that is diazonium salt boil with water, you will get hydroxy. So, one hydroxy, one chloro, like this 2 different groups. By how do you convert nitro into one bromo, one chloro, means this partial reduction method will be applicable, right. So, these are all comes under the beautiful the applications of the diazonium group by replacing the diazonium group into the totally new group. Okay. Now, the second type of applications we will have by retaining the nitrogen group. By retaining nitrogen function. There are again 2 types are there. Both the nitrogens you can retain, one nitrogen you can retain. The first type is the reduction. Second type will be the coupling reaction. Coupling reaction and the reduction. In the reduction, there are again 2 types are there. Total reduction, partial reduction. In the total reduction, diazonium salt is reduced, N2Cl is reduced, or you can write like this also, N double bond NCl, okay, reduced with tin and HCl is a strong reducing agent, liberate the tin chloride and the nascent hydrogen. That nascent hydrogen will cut this bond and you will get this side you will get aniline, the other side you will get ammonia. Total reduction of the diazonium chloride will give the aniline one side, the other side ammonia molecule NH3. However, both the molecules under the influence of HCl, therefore, they are coming as a hydrochlorides, or you can write NH3 plus Cl minus, NH4 plus Cl minus. Salt of the ammonia, salt of the aniline will be answers. This is called total reduction. Partial reduction means the diazonium chloride, it's not cut into the pieces, right? But the reagents are stannous chloride and HCl, or sodium stannite. There are huge number of list of the reagents are there. They also liberate the nascent hydrogen, but in a small quantity or in a lower dose. So therefore, partial reduction takes place so that the double bond is reduced into single bond NH2. These are called this is a phenyl group containing hydrogen. Phenyl hydrogen is formed. Phenyl hydrogen. So partial reduction leads to give the phenyl hydrogen formation. In the second type of the reaction, under this two type of the nitrogen retaining the group, the coupling reaction, coupling with the phenols, as well as you can find with the amines also. Let us take first phenols. You take a phenol, dissolve in sodium hydroxide in 10% NaOH you take and dissolve it. So phenol is acidic, therefore it is soluble in the sodium hydroxide. Then you add this diazonium chloride. Diazonium chloride itself will have a slightly orange colored water soluble compound. It is dissolved in water, that solution is added. The whole group goes and attacks at the para position of the phenol. Phenol is a strong activating group. In basic medium, it looks appears as a phenoxide, sodium salt of the phenol. Sodium phenoxide is a strong activating group. Therefore, the entire group goes and coupled with the phenol. You will get both molecules are joined through the NN. A big compound is formed, which will have a beautiful red colored azo dye is formed. However, a simple phenol with a simple diazonium chloride will give the azo dye red colored, but we have a huge number of different other colors depending upon containing the phenols. As the naphthalene, you can have anthracene. In the phenols also you can have some sulfonic groups, other dimethylamine groups and so on, so that they are also activating, and red color, crystal violet or Congo red, different types of the colors also can be produced by using. These are all azo dye. In the printing industry, they are used as a dyes. Dye means it's a color which is enough to catch the fiber. So even if you wash also, once it is printed on the fiber, whether it is cloth or synthetic, when it is printed on the cloth, it will bind with the cloth. So therefore, the color will be the last, or the stays for the longer time. Even after washing also it won't go. Such a colors are called dyes. Colors are not simple. All the colors are not dyes. All the dyes are colors, but all the colors are not dyes, because color may be water soluble, color may be washable. But here this is a one which is when treated with the fiber, it reacts and makes a chemical reaction. Still the color is there. So this NN group is a color producing group called chromophoric group. That group is responsible. If it is reduced, for example, HH is added, this benzene separate, it will become colorless. So the NN group is responsible for the extended conjugation, therefore the compound is colored. Similar the case, the reaction also takes place with amines also. With aromatic amines also, they couple. The aniline you take, dissolve in the 10% HCl. Notice that in this case, it is acidic. Phenol is acidic, therefore soluble in the base, dissolve it and prepare a solution, then add. Here aniline is basic, so that's why dissolve in the dilute HCl, make a solution, and then add this reagent. The whole group go and couple with this amine. You also get once again a red colored azo dye. This is benzene is same, but here you will have an amino. This is called amino. Okay, azobenzene. This is hydroxy azobenzene. Both are called azo dyes. They are useful as a azo dye. As I said, dye is a used color used in the printing industry, textile industry. So therefore, either way, this is a weak electrophile. On the benzene, there is no reaction. However, when there is a strong the activating groups like OH or amino substituted OH like OCH3 or OCOCH3, better is alkylated. Here also N-alkylated, monoalkylated, dialkylated, both alkylated amines and the phenols undergo this reaction. This is a azo-di preparation. In this reaction, the reaction takes place. You can also notice that what is the role of this NaOH. NaOH, this is an organic compound soluble in water. This is also soluble, but as the number of carbons in the hydroxy, so phenols, alcohols are soluble actually, but the number of carbons increased. Here 6 carbons are, so phenol is insoluble in water. So because if methanol, ethanol is there, soluble, but a 6 carbon compound, hexanol and the phenols are insoluble. So this is insoluble in water, this is soluble, so therefore there may be 2 phases, the reaction will be slow. So you make a solution, that is the phenol dissolved in sodium hydroxide, sodium phenoxide, which is soluble in aqueous medium. Add the aqueous medium, that is diazonium chloride, it's a salt soluble in water, aqueous solution, you add it, the whole reaction takes place smoothly in the reaction. So sodium hydroxide, one role is it is working as a solvent, role of the NaOH, one is solvent. It is able to dissolve this one and makes the solution free. So sodium salts are soluble, so therefore it is working as a solvent. One point it is. Second one is a phenol becomes into phenoxide. The phenol is also OH is an activating, but when it becomes sodium phenoxide, in the presence of sodium hydroxide, phenol becomes phenoxide. Sodium salt of phenol is known as sodium phenoxide. This phenoxide is more activating because plasma activity will be stronger. When OH is there, lone pair has to attack. Here the minus charge is attacking, so minus charge will donate there more easily. So therefore phenoxide is a strong activating group than the phenol. So in basic medium, phenol converts into phenoxide. So we have some certain reactions like a Kolbe-Schmidt reaction, like Riemann-Teimer reaction. These are all base catalyzed electrophilic substitutions. In the base, the phenol converts into phenoxide. Phenoxide is more reactive, therefore diazo-coupling reaction very easy. Only phenol, literally the reaction will not take place. Very strong activating like phenol, activated in the basic medium phenoxide, so therefore the reaction is successful. Similar the case here also, the role of HCl is, if you take in this case, if instead of NaOH, if you take the HCl, in the HCl acid, phenol is acid, won't be soluble. If you take too much base also, strong base, if you take, what happened, diazonium chloride converts, strong base if you add OH minus, the diazonium salt will become to N double bond NOH. This is no more a electrophile again. So strong base, greedy is also not useful here. Anyhow 10% sodium hydroxide is helpful, so therefore let us add concentrated base, means in concentrated this attacking species electrophile will become into a stable electrophile like this. The bond will not be dissociated, you won't get plus on the N, so therefore attacking will become problem. So you should not add a strong base also, dilute sodium hydroxide. Here also strong acid, if you use aniline is soluble in the HCl, but if you take strong acid, this will become anilinium chloride, NH3 plus Cl minus. NH3 plus is a deactivating group, therefore reaction will fail. So in bases used, we need acid but dilute acid. When phenol is used, we need base, but it is a dilute base is used. Okay, 10% NaOH is enough to make solution and as a solvent, and the other one is activating group. Phenol turns up into the phenoxide. This is the main application. Phenol turns into phenoxide. Phenoxide is strong, more reactive towards electrophilic substitution, therefore the weak electrophile. This is the resonance stabilized electrophile, therefore the reactivity will be less. So diazonium chloride generally will not attack on the benzene, and the deactivating groups like nitrobenzene, all deactivating compounds will not undergo diazo coupling, but phenols and amines, the two specifically in these conditions the reaction takes place. Both the reactions are very much successful in the preparation of the dyes. So second type of reactions are by retaining the nitrogen, that means in the N2Cl, either in the one nitrogen or the two nitrogens we are able to get in the product nitrogen is there. So this is the second part of the application of the diazonium salts. So with this the nitrogen compounds topic is over. So in the nitrogen topic we have taken the first class, the nitrogen containing compounds amines, 1 degree, 2 degree, 3 degree amines we have taken. And in this class cyanides, isocyanates, and the diazonium salts we have taken. All these come under the topic called what? Nitrogen compounds.